what is a pure function? Well, a pure function looks like this. We have a function. So instead of a box that we had before of objects of all these functionalities, instead think of this as just a simple function. And let's say we give it a list containing 1, 2, and 3. If we give this input into this function, what we would expect with a pure function is for something to happen to this input that every time results in the same thing. So let's say we multiply this by 2, we would receive 2, 4, and 6. Now, a pure function has two rules. One is that given the same input, it will always return the same output. That is, every time we give 1, 2, and 3 to this list, we give it to a function that we create, it should always return the same output. So if I run this function millions of times with the same input, it should result in the same output. And the second point is this idea of a function should not produce any side effects. What are side effects? Side effects are things that a function does that affect the outside world. For example, if I was to print something inside of this function, it affects the outside world, right? Because I'm printing something onto a screen. The screen is the outside world. Or for example, if this function was touching a variable that lived outside of a different scope, that's a side effect. Let's have a look at code to understand this concept a little bit more. Let's say we had a function, and then this function will multiply by 2 a list. So let's just say an li, which will be our list. And in here, what we want to do is loop over the item in the list. And then each item, we want to multiply and append to a new list. So let's create a new list. That will be an empty list. And in here, we'll say new list dot append and do item multiply by 2. And then finally, at the end of this function, we want to return the new list. Let's give this a go. If I say multiply by 2 and give it 1, 2, 3, and let's print out here the output. If I click run, I get 2, 4, 6. Is this a pure function? Let's think about this. The first rule, given the same input, that is 1, 2, and 3, it will always return the same output. No matter how many times I run this, it's always going to give me the same output. So, okay, we passed the first test. What about the second test? That it produces no side effects. Does this produce any side effects? Does this touch anything in the outside world? Think about it. No, it doesn't, right? Nothing in the outside world matters to this function because everything is contained in here. If, for example, instead of having print here, we simply have print in here. If I click run, we get the same output, but does this have side effects? Well, yes, it does. It interacts with the outside world, which is the print statement. The print statement tells me, hey, I'm going to print on whatever the display this machine has. In our case, it's going to print here, but we don't really know what print statement does because it interacts with the screen on this side. So this has side effects. We give control to print, but we don't know what print is going to do. Another example that I can give you is this. What if we have a new list here that we actually define outside? Like so. So that we have new list like this. If I click run, I still get 2, 4, 6. But does this have side effects? Well, yes, it does. It interacts with the outside world. And what's outside of this world of a function, which remember is the scope? Well, it interacts with this new list. It appends to this new list. So if a programmer comes along and maybe before we run this function, we decide to say new list, we change it to an empty string. Well, when I run this function, I get an error because now this new list is a string object. So the new list that lives in the outside world of this function can be modified by another developer or by a program, and we wouldn't know about it. And when we run this function, it's going to give us an error. It has a side effect. So ideally, we contain our functions and make them pure. Because as you can see, we're never going to have a bug or an error in our code unless we wrote something wrong here. But because we don't care about the outside world, because everything that we give as an input is always going to produce a good output, it's going to be pure. Now, it's hard to really understand why this is such a powerful concept without having a bit of experience in the workplace. But let me just tell you this, that when you have pure functions, you have less buggy code. You're able to test your code better. It's easier to understand your code. And overall, you have these benefits of not having different parts of your code touching each other and affecting each other, which makes your life as a programmer so much easier. So this idea of pure functions is really important. But the one thing I want you to take away from this is that pure functions is more of a guideline than an absolute. It is impossible to have pure functions everywhere. Because if a function doesn't affect the outside world at all, well, we wouldn't have any programs. We wouldn't be able to display things. We wouldn't be able to save things, such as our game profile. So it's impossible to have pure functions everywhere. However, when you can, wherever you can, functional programming teaches us that pure functions are good. Try to create pure functions and only have few non-pure functions that maybe interact with the outside world that we can go back to whenever we have bugs in our code, because most likely those are the ones that are going to have bugs than pure functions like this. To finalize our concept of functional programming, if, for example, this was our wizard from the previous videos, with functional programming, we would have a wizard object or wizard dictionary that had name, let's say Merlin, and power of 50. And instead of containing these in a class, I would have different methods, such as attack. And this wouldn't be a method, it would be a function because it doesn't live inside of a class. In functional programming, they say, hey, we don't need to combine data with functions. Let's keep those separated. Let's just create pure functions that can be passed anything, like a character. And this way, we keep those two things separate so that we can focus on pure functions and we can focus on data. So that's where the difference is. At the end of the day, it's all about trying to keep our code clean and avoiding bugs in our code, a big problem that programmers have all the time. So it's just a different way of thinking. Let's learn some more in the next video.